Hey guys, welcome back. So today we're on day 2 of figuring out the unit circle. We're going to learn another big piece of it before we're able to finally put it all together. And let's just jump right in and get started. So we talked all in yesterday's about degrees. I never even said the word radian at all. It's a vague word to you guys that might be in your brain somewhere from geometry, but it really doesn't have a strong importance until right now in the unit circle. Is really the first time it makes a big appearance and is very, very important, and we actually use it all the time. Whereas in geometry, we kind of just taught it to you, and we didn't necessarily use it a lot. So let me remind you just what radians are. 180 degrees, which we learned yesterday, is just half of a circle. So starting at 0, going counterclockwise, which really just forms a line, we get the 180 degrees. Well, radians is just another way of measuring angles. So instead of using the unit degrees, we can use something called radians. And the equivalent value is that in 180 degrees, there are pi radians. So if I start at 0 in radians and go half of a circle, I'm at pi. And this might seem weird. We're not saying like you've gone 3.14 in distance or anything like that. Again, we're measuring this angle. Instead of 180 degrees, we can say this is pi radians. And that's that other mode on your calculator that often you guys have had to change back and forth between to make sure you're in degrees. That other one has been radians. And so you can tell just by where it is on your calculator that it is important. We just haven't really seen it come up yet. So we know that pi radians is the same exact thing as 180 degrees. So this is pi. Pi radians lives right over here next to 180 degrees. These are at the exact same spot. So, okay, well, in degree world, let's go back to degrees. If I were to go another 180 degrees, I'm at 360, going all the way around the circle. Okay, well, if I'm at pi radians and I go another pi, what would I be at? I'd be at 2 pi. Okay, so that kind of just gives you a feeling into what radians are. Pi radians is 180 degrees. All right, so let's think about the fraction pi radians, I'm just going to say RAD, over 180 degrees. If these are the exact same thing, then something divided by itself equals, so think about that, something divided by itself equals 1. And the same exact thing would be true if I did it the other way. If I said, what if I put 180 degrees on the top and pi radians on the bottom? Well, these are equal. They're the exact same thing. So this fraction is still just 1. Okay, so I'm going to write actually this part neater and show you just a quick example before I move on. If I have 50 degrees and I tell you convert that, so let me write degrees, convert that into radians, then I want to choose to multiply it by this, pi radian over 180 degrees. The reason I would choose that fraction is because if I think about, well, there's degrees in the top and degrees in the bottom, they would just cancel out. So then I'd be left with something in radians, which is exactly what I wanted. Okay, and I won't go through and multiply that out. We'll do that in a second. But let me show you the other way. What if I gave you something already in radians? So like something like pi over 2. By the way, radians, it's always pi over something. There's always pi included in your answer. It's never ever going to be like 3.7 radian. It's always going to be some fraction with pi. So if I have pi over 2, and this is radian, and I want to convert that to degrees, then I would multiply by the one where radian is in the denominator. That way radian here and here will cancel. So that means that I put radians in the denominator and degrees in the numerator. And since the radians cancel out, I know that I'll be left with a number that's in degrees. Now, the cool thing too is if you notice there's a pi in the numerator and the denominator. So all that has canceled out as well. And so really the only math I have to do is 180 divided by 2, which of course we know is 90. So pi over 2 in radian, what I originally had here in red, is the exact same thing as 90 degrees. Okay, we're going to do lots more examples of those. It's really important you can go back and forth, so we're going to be doing lots of examples both ways. Okay, so let's convert these to the opposite one. So if it's in degrees, convert it to radian. If it's in radian, which is this one, then convert it back to degrees. So looking at the first one, 120 degrees. since that's degrees, and sometimes it's literally helpful to write it in, then I'm going to multiply by the fraction where degrees is in the bottom. That way, these units will cancel, and I'm left with radians. So, that's how I'm choosing which fraction to use. Okay, so since I am converting this to radians, pi will always be in my answer. So what I will not do, so this is like, don't do this, don't just type in 120 times pi divided by 180 and get some crazy decimal. I want pi to be in my answer. So all I'm going to do is simplify this fraction, okay? I will not multiply the pi out. All right, so let's go ahead and do that. Let's simplify the 120 over 180 degrees. If you just type that on your calculator, you'll see that you get like 0.6 repeating. And then hit the button that says Math, which is third down from the upper left-hand corner on a graphing calculator. If you hit Math, and then it's already highlighted on the button that says Frac for fraction, hit Enter, and then hit Enter again, and that will turn that into the most simplified fraction of whatever you typed in. And that gives me 2/3. So let me erase that. That's calculator work. So 120 divided by 180, when I divided that out, I got 2/3. But remember, I still had this pi here, so there was still a pi in the numerator. And so I just converted 120 degrees to radians. Here's how we say it out loud, 2/3 pi. So another way you can kind of write it is the fraction, and then you could write the pi afterwards. Either way, it doesn't matter. You could write it like this or this. How you say it out loud is 2/3 pi. Okay? All right, let's do the next one. I have negative pi over 12 degrees. Remember, that just means if you were graphing this, that means you start by going clockwise. So you start by going down. Converting that to degrees is no different, though. We can still do it the exact same way. We just know we're going to have a negative degree. So since this is in radians, again, I think it's really helpful to actually write the unit you have, because then you know that unit needs to go in the denominator. That way these cancel. So fill in your fraction. Okay, and now I just need to figure out what number this gives me. Well, the other really easy thing is that the pi in the top and the bottom also cancel. So a lot of things have canceled. All I really have to figure out is 180 divided by 12. Remember, that is a negative 12. If you type that on your calculator, you get 15. Since that was a negative, I still have the negative. So I know that's negative 15 degrees. If I do this degree symbol, I don't need to also write it out in words. And I'm done. So easiest way for these is just whatever unit you start with, like if you start with degrees, make sure the fraction you multiply it has that unit in the bottom. That way it cancels out. Okay, so I need you to try 4 of these on your own to make sure that you are getting it. One thing I will say before you get started is a lot of people might look at this and think, oh my goodness, like that must be degrees because there's no pi in it. And that's actually not true. So notice that anything that's in degree will have this degree symbol. Anything that doesn't have a degree symbol is automatically radians. So even though this does not have pi in it, and like I just said earlier, normally there is pi in your answer. This is a weird one where there's not pi. And that just means in your final answer there won't be pi because we started without pi. And so this is radians, and I know that just because there's no degree symbol. Okay? So, you know what, maybe I'll just do this one with you. Since that's radians, I'm going to write in RAD for radians. I know it's radians literally just because there's not a degree symbol, which means I need to multiply it by the fraction where radians is in the denominator. So pi radian in the bottom and 180 degrees in the top. And again, the reason we do this is because radian in the top and bottom will cancel. So my answer will be left in degrees, which is what we want. Now, since there's no pi in this problem to begin with, then this pi down here cannot cancel with anything. So this one, we are going to just have to multiply all the numbers we see. So on your calculator, type in negative 6.28 times 180. I would hit enter there, and when I type that in, I'm getting negative 1130.4, and then you're going to divide it by pi. Okay, so you should be getting about negative 359.8 radians. And again, this is abnormal because normally we do have pi in our answer when we have radians. The only reason we didn't is because this problem started without pi to begin with. Okay, now you might notice that this is really, really close to negative 360 degrees, which is really close to going all the way around the circle. So that means to begin with, my number, negative 6.28 in radians, must have also been really close to going all the way around the circle. So let's just explore that for a second. And it was negative, so I am going to start, when I start at 0, I am going clockwise, so I'm going to start by going down. So if I go all the way around the circle, what is that in radians? Well, remember going halfway, and I'm going backwards, so this would be negative pi. And then if I go another halfway, this would be negative 2 pi. Type that on your calculator. Negative 2 times pi. And what you get is negative 6.28, which makes sense why we got something really, really close to negative 360 degrees, because we did go all the way around the circle in radians. The reason I didn't get exactly negative 360 degrees is because the decimal was not negative 6.28. It was much longer. It was like negative 6.28, 318, 5307, blah, blah, blah. It keeps going. So unless we had included all those decimals to begin with, then that's the reason why we're not getting exactly 360. Okay, cool example. Now let me clear this off and have you guys do 9, 10, and 11, and hit play when you're ready to check your answers. All right, number 9. Since it's in degrees, you want to multiply by the fraction that has degrees in the bottom. That way, degrees and degrees cancel. Okay, my answer will be left in radian, which I want to keep a pi in my answer. So I just need to simplify this fraction, 135 divided by 180. When you type that in and get your simplified version, you get 3/4. So this should be 3/4 pi. Okay? Number 10, negative 40 degrees. Since degrees is my unit, put degrees in the bottom. That way your unit of degrees will cancel and you'll be left with an answer in radian. So degrees and degrees cancel. I want radian in my answer. And so I want to keep pi, so I just need to simplify this. So 40 divided by 180, and then simplify that fraction is 2/9. Since it was a negative, though, make sure you kept the negative in your answer. So that's 2/9 pi, and that is the equivalent of negative 40 degrees in radians. Okay, number 11. I'm in radians. If it helps you to write in radian, then do that. So I'm going to times that by 180 degrees over pi radian. And I'm doing that because radian and radian will cancel. Also, pi and pi cancel. So all I have left to do is 5 times 180 divided by 4. So typing that in, 5 times 180, hit enter, divide by 4, you get 225 degrees. So 225 degrees is the exact same thing as 5 over 4 pi. All right, number 12 we already did, so we are good to go converting back and forth between radian and degree. At this point, I am going to move on from going back and forth from converting. So if you need to review this part, I would not recommend continuing the video because you're going to get confused. So if you need to review this part, go back, do a few more of these, or pause, listen to it slowly, but make sure you got this down before you continue on. So let's go to the second part now of this lesson. We talked a lot yesterday about how to get degrees in a circle, in the unit circle. So if I just pretend for a second that this said degrees, remember some of the things we talked about was we always go counterclockwise. We know that each one of these represents 90 degrees, so I can go around and get 360 degrees in one turn, and I could just keep going. So how do I figure this in radians? And I talked a little bit about it earlier, but we know that going halfway around the circle was pi radian. So right there is pi radian. It's the same thing as 180 degrees. All right, so I want to basically ignore the bottom half. Let's just work with the top half. If this is pi, 1 pi, then if I were to take that and just cut it in half, so this whole thing, this whole top half, all highlighted in green is pi. If I were to take pi and cut it into 4 equal parts, then each one of those would be 1/4 pi. This would be 1/4 pi. This would be 2/4 pi. This would be 3/4 pi. And then this gives me 4/4 pi, which is pi. So this is what it would look like if I were to cut it into equal 4 pieces. It's the same thing as just like when you learn fractions in elementary school and you imagine like taking a piece of pizza or cutting pie and you cut it into 4 equal parts. That's all I've done here. I have slices of pie or pizza, whatever you want to think about it, in 4 equal parts. 1, 2, 3, 4. And I've labeled them accordingly. 1/4 pie, 2/4 pie, 3/4 pie, 4/4 pie, which reduces just to 1 pie. Okay, so let's just simplify some of these fractions. The only one I can really simplify is this one here, 2/4 pie. 2/4 we know is the same thing as 1/2. So this is the same thing as 1/2 pie. And does that make sense with what we know? Well, if this is pi going 180 degrees, then that means halfway should be 1/2 pi. And that's exactly what we got when I reduced that fraction 2/4. All right, so let me clean this up a bit. All right, so reducing my fractions, I get this, taking the top half of the unit circle and just dividing it into 4 equal parts. Notice also what I did is instead of writing it like 1/2 pi, I just said pi over 2. And that's actually how we're going to write it. Instead of like leaving it like longer like this, just condense it. Write pi divided by 2. Okay, so let's keep going. Remember I left off, so I was at 1/4 pi, 2/4 pi, 3/4 pi, 4/4 pi was technically where I left off. That just canceled, and that's why I wrote pi. But let's keep going. If I were to continue splitting this into equal fourths, let's do the bottom half, then I would get 5/4 pi, 6/4 pi, 7/4 pi, 8/4 pi. And I can reduce a lot of these. So this 6/4 reduces to 3/2. So I'm going to erase that and just write 3/2. And another one that'll not cancel, but reduce, is this one over here. 8 divided by 4, that's just the number 2, so we know that this would be 2 pi. Okay, and actually we knew that from earlier because over here is pi, which means if you just go another like halfway around the circle, you should be at 2 pi. So this is what the unit circle looks like if I were to divide the top half and the bottom half into equal pieces of 4. All right, now I want you to imagine, instead of me just erasing this, what if I had started this problem and asked you to divide it into halves? So I started here with pi, and I say divide it in half. You would divide it in half right here, which makes sense then why I would mark that as 1/2 pi. And I didn't say it like that earlier. We had done it in 4s and just reduced our fractions, and now you can see exactly why that one does reduce to 1/2. Okay, so let's keep going and label our other halves. Let me actually outline all of them in red. So I'm going to just outline the circle. And hopefully you can visualize this. This is like cutting the top half into 2 pieces and cutting the bottom half into 2 pieces. So I did my first one, 1/2 pi up here. And then this would be 2/2 pi, which that just cancels. And then my next one would be here at 3/2 pi, and my next one would be here at 4/2, which 4 divided by 2 just reduces to 2. Okay, so that's why this title is called in 4s, so you automatically get 2s, because when you divide the entire unit circle into 4, so you divide the top half into equal groups of 4 and the bottom half into equal groups of 4, you are automatically, by reducing your fractions, you've also shown the ones where you divide it into halves. Okay, let's do the same thing, but dividing it into 6 equal pieces. So if I take pi, which is halfway, and I divide it into 6 equal pieces, it would look like this, kind of. Pretend that's exact. And this would be 1/6 pi, 2/6 pi, 3/6 pi, 4/6 pi, 5/6 pi, 6/6 pi, which we know that just reduces to pi. Let's see what else reduces. Well, this one here, we've seen that a couple times now. 3/6 is the same thing as 1/2, so I'm going to write that as pi over 2. What else can reduce? This one right here, 2/6, that's just the same thing as 1/3, so I'm going to write that as 1/3. What else reduces? This one here, 4/6, that reduces to 2/3. And I think we got them all. And I can continue doing the same thing to the bottom half. So let's keep going. I left off at 6/6, so this would be, actually let me divide it nicely before I label. So then this would be 7/6 pi, 8 over 6 pi, 9 over 6 pi, 10 over 6 pi, 11 over 6 pi, and 12 over 6 pi. And if I reduce my fractions on a bunch of these, so let's see, this one can reduce 8 over 6. That's just the same thing as 4 over 3. Other ones that can reduce is this one, 9 over 6. That's the same thing as 3 over 2, which we knew that from when we cut the circle into half, so that was the third one. Right here, 10 over 6. That can reduce to 5 over 3. And then this one over here, 12/6, that can just reduce to 2 pi. And we already knew that one. Okay, so now I want you to imagine, this is what the unit circle looks like if I divide it into sixths. Now, I want you to imagine, what if I had asked you to do the same thing but divide it into thirds? So here's pi, divide it into 3 equal pieces. So here's my equal pieces. Here's the first piece, the second piece, the third piece. Well, that should make sense then why this line was 1/3 pi. I just divided it into thirds. And this line was 2/3 pi. That was my second one. And this was 3/3 pi. Right? And this can keep going. 4/3 pi, 5/3 pi, 6/3 pi. So if I divide it into thirds, I would have gotten the ones circled in green. But I did not have to divide it into thirds and divide it into sixes, because when you divide it into sixes, you automatically are getting the thirds just by reducing your fractions. All right, so now we should be able to put all of them together by dividing the unit circle into 4s and into 6s, and you get all these what kind of look like spokes. All right, so I like to start by just putting my pi and 2 pi. Right, and you can also think about this as 0, starting at 0 and ending at 2 pi if we go all the way around. And I'm going to first start, and I would recommend you guys always start this way, is start by dividing everything into 6s first, because you get a lot of them. So think about taking this whole top half, and I'm going to divide it into 6 equal pieces. So I'm going to highlight, I call these like the spokes kind of. I'm going to highlight the spokes that represent cutting it into 6 equal pieces. And it would be these ones. And then go through and fill it out. So this would be like 1/6 pi, 2/6 pi. And I know that fraction can reduce, but I would fill it all out. That way you just kind of get in the flow of like 1, 2, 3, 4, and you keep going. And then at the end we'll go back and reduce them all, but that way we can just get all the numbers written down. So 3/6 pi, 4/6 pi. Let's just keep going. And I would fill it out and it would look like this. And again, I'm going to keep going and finish before I reduce these. So that's most of them. The only ones I didn't get was the ones when I cut it into 4 equal halves. So if I cut this top half into 4 equal pieces, you would get what's highlighted in blue. And now I'm going to go fill these out. So this first one would be 1/4 pi. So I'm going to write pi over 4. 2/4 pi, but that's just 1/2 and I already had that. 3/4 pi, 4/4 pi, which I already had as pi, 5/4 pi, 6/4 pi is the same thing as 9/6, and then 7/4 pi, and then 8/4 pi, which we already know is 2. Okay, so now let's just go through and reduce anything that can be reduced with the fractions, like ones like this, like 2/6, let's just write that as 1/3. Or we could say that as pi over 3. Things like this, 3/6, that's the same thing as 1/2 or pi over 2. 4/6, that reduces to 2 over 3. Right, so just go through and simplify any of the fractions that can be simplified. Okay, so here's just a nice clean picture of what that looks like when you reduce all those fractions. This is a really important picture right here, and this is what you're going to just need to be able to fill out really, really quickly moving forward. I will give you some hints on like how I do it faster. Is I always see like the ones that are over 6, the ones that like don't really end up reducing any further, these 4. Notice that, like, if you draw a rectangle, these would form a rectangle. And I know that's a terrible rectangle. And then the ones over 4, notice those are always in the middle. And if you connect these form a rectangle. And then the ones over 3, these are kind of the ones on the edge. These form a rectangle. I know I'm drawing terrible rectangles, but if you consider, like, that they should be mirror images of each other, then you won't have ever get an issue of, like, accidentally, like, flip-flopping these. So I don't always actually draw these rectangles in, but it just helps me make sure that they're all in the correct order. Other small things is, if you notice, the ones over 6 are closer to the x-axis, and then the ones that are over 3 are closer to the y-axis. That's kind of another one that helps me remember. But really the easiest way is just going through and filling it out like I did in the last slide, where you just whip right through, like 1 over 6 pi, 2 over 6 pi, 3 over 6 pi, and then reduce all your fractions. Okay, so questions that you will be asked of this section are like this. It'll ask you to graph in standard position, just like we did last time. So where is 3 pi over 4? Since the fraction is over 4, we're going to divide the unit circle, each half, the top half and the bottom half, into 4 equal parts. And it would look like this. So this would be the first one. So this is, you can think of it as like 1/4 pi, 2/4 pi, 3/4 pi. And that's what it was looking for, was this one right here. So I know that that's where that was. So I'm going to erase this other stuff. And normally you don't draw on the other stuff, but once you get the unit circle memorized, you'll just know that that's 3 pi over 4, and that's where that angle is. Remember, vocabulary, this is the initial side, and this is the terminal side. If I flip back to this screen, you'll remember that that was the one right there. Okay, how about part B, negative pi over 3? Since this is in thirds, I'm going to take the unit circle, and this is negative, we're going this way, so I'm going to just work with the bottom half of the unit circle and divide it into 3 equal pieces. Okay, and so the first one back is going to be my negative 1/3 pi, which is the same thing as just negative pi over 3. So this one right here is the angle that I want, so I can erase the other ones. Remember, this is the initial side, and this is the terminal side. The other way, too, that I could have gotten it quickly, looking back at this picture, remember that was the one that matched up here. I couldn't have known that it was at 5 pi over 3, because if I started at 6 pi over 3 and just subtracted 1/3, which is the same thing as negative pi over 3, then I'd be at the 5 pi over 3. Okay, part C, I want to go 11 pi over 6. So divide the unit circle up into 6 equal pieces and count all the way around until you get to 11 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 6 would be right there. So I'm going to erase that, and I really just want that one particular spoke. And again, vocab-wise, here's the initial side. This is where we started with. I went all the way around, and I ended up right here. And so all this distance is 11 over 6 pi. Okay, last one is 7 pi over 2. Since it's over 2, that means I'm taking each half of the unit circle and dividing it in half. And I want to go until I have 7 of them. So here's 1, 2, 3, 4. I'm still not there. 5, 6, 7. So right here is where I want. And how I would draw that in is I had to go all the way around and then almost around twice to get to that. So I would just show that extra loop in there when I mark that angle. Okay, I want you guys to pause the screen and try these 4 on your own and hit play when you're ready, and we'll check your answers. Alright, so here's the first 2. I'll do the last 2 with you. Pause if you need to look at these first 2. I'm going to start right now on part C. It's 8 pi over 3, so divide it into thirds. So that's the top half of the circle into 3 equal pieces, the bottom half of the circle into 3 equal pieces, and let's count. 1, 2, 3, 4, 5, 6, 7, 8 would be right here. So here's my angle, but I'm going to show it like I had to go around a full time once and then to that. Alright, and last one is I want to go negative 5 pi over 4. So divide it into 4 equal pieces, both the top and bottom half, and count. So negative 1, 2, 3, 4, negative 5 would be right here. and just mark it in showing that we had to go this way. Alright, so that's it for today, you guys. If you understand this picture and have this memorized, then you are all good to go. Have a good day, you guys.